He's given me an assignment, right? Why is he giving me an assignment that is so late on a Friday? And the reason why is we just had we're trying to get together and do things the best we can as teachers, and they'd rather have us get them out early. So this is, yes, it's late on a Friday. You don't have school on Monday the 7th, but when we get back on Tuesday, this is here. So if you get a chance to get ahead, that's fine. But this is the assignment for September 8th, Tuesday. Cool? All right, so here it comes. Let me jump off of this. What I'm going to do is I'm going to go over a presentation, and then I'm going to go over the worksheet with you. Okay, so this might be kind of longer, but it's all here. Okay, so we're starting a new topic called isotopes. And it may be something that's going to be review and some things that are going to be new. Coming into chemistry, you should know that atoms are made up of protons, neutrons, and electrons. You should know that. Okay, should be review. You should know that protons have a charge of +1, electrons have a charge of -1, and neutrons have a charge of 0. They have no charge. Okay, and you should also know the weight. You should know the mass, that a proton weighs 1, a neutron weighs 1, an electron weighs 0. You should know those two things. And then you should know that the proton that weighs 1 and the neutrons that weigh 1 are in the nucleus. That the electrons are in what's called the electron cloud, or the electron rings. Okay, you should know that. Here it is just in case. But I'll say it one more time. Atoms consist of these subatomic particles called protons, neutrons, and electrons. The weight comes from protons that weigh 1 and neutrons that weigh 1. Electrons weigh 0. It's a cloud of energy, but with no weight, no mass. Okay, and that the protons and neutrons are in the nucleus and the electrons are in the electron cloud. Protons are +1, electrons are -1, neutrons are neutral. Okay, this guy named Dalton, you probably need to know him. You're going to see him sometime on a test. Dalton was the one that really determined and created these things called atoms made of these subatomic particles. And he said that atoms of any atom, no matter what it is, will have identical properties, right? So if it's carbon, it's going to have the same properties of carbon that's in Nevada, or if it's in, I don't know, in Africa, it's going to have the same properties. Okay, and these atoms cannot be created or destroyed. They are just exchanged. You're going to learn, you've all seen the periodic table, and the number for the mass that you see on the periodic table is called the atomic mass. Right? So when you look at the periodic table, and I have a periodic table for you, on this Google Classroom, but when you look at the periodic table, like for carbon, okay, it's 12.011 is the atomic mass for carbon. Okay, so my question to you is that if carbon is made up of protons and neutrons for mass, and a proton weighs 1 and a neutron weighs 1, then how can it be 12.011? That's like me saying, if I have 6 students, how many arms do I have? I should have 12 arms. If I have 6 students, there should be 12 arms. How can I have 12.011 arms? That's kind of weird, right? And the reason why is because it is an average. It is an average. Not all carbons weigh 12.011. Some weigh more and some weigh less. This is an average. You guys got it? So if you were to go and have a bonfire tonight, because it's kind of chilly, and you get some nice trees and you burn them, and tomorrow morning all of that ash and that charcoal, you smash it up, that's carbon. For every 1 mole, it's going to be about 12.011 because it's a mix of carbons that are heavier and carbons that are lighter. Mrs. Jensen has all the 9th graders in science in her room. Mr. Tim has all the 11th graders in science, and Mr. Pierce has all the 10th graders in science in his room. We weigh each one of them. We divide the total weight by the total students, and we get an average of 9th graders weighing 137.5, 11th graders weighing 172.8, and 10th graders, sophomores, 146.3. So if we were to take a sophomore or several, let's say we took 35 sophomores, the average of them would be close to 146.3, the average weight of them. Okay? But if we want to talk about specific sophomores, not the ones that weigh 146.3, we want to talk about Mark, who weighs 151. This is how we write it in chemistry, right? The average, that's the atomic mass. It's on the bottom of the periodic table. But when I want to pull one single carbon out, when I want to pull one carbon out and talk about it, I write carbon here and I write its weight. Just like I say Mark at 151. Okay? Now there's one more thing you must know. So you say to yourself, okay, great. I get it. Mr. Pierce says that carbon, right here, the average is 12.01. That's the average amount of all of the different carbons in the universe. The average is 12.01. But the only thing that makes up mass is protons and neutrons. Electrons have no mass. And I think I remember, if not, Mr. Pierce is going to help me remember, that if anything has 6 protons, if any atom in the entire universe has 6 protons, it is carbon. Remember, the number of protons identifies the atom. Okay, so when you look at this periodic table, if something, this number here is called the atomic number. It's the number of protons, and it also tells you the number of electrons. Okay, so carbon, neutral, is going to have 6 protons. That makes it carbon. Nitrogen is going to have 7 protons. That makes it nitrogen. Oxygen is going to have 8 protons. That makes it oxygen. So if the weight changes, it's the number of neutrons that changes. Because if the number of protons change, the atom, the element itself has to change. Right? If we take carbon, right here, carbon, and it has 6 protons, and we find a way to put another proton in, boom, it becomes nitrogen and all of its properties, okay? So I just want you to know that. So the atomic number is up here on the periodic table, like we said, and the atomic mass is on the bottom. When you look at the periodic table, it is the averages. And then remember, when we want to talk specifically about a specific type of atom with a specific number of protons and neutrons that is different than the average, then we pull it out in this fashion. We write it like this, right? This is called it's done in isotopic nomenclature is what it's called, right? That's how you write it down as an isotope. So here we go. Writing sodium down as an isotope. Okay, this number is not right here. This number is not the atomic. Let me go. I'll go black. Okay, this number is not the atomic number anymore. It's called the mass number. It must be a whole number because remember, protons and neutrons are whole things. You can't get 0.01 of a person. They're whole things. So this number will always be a whole number. And then this number is the atomic number. The atomic number tells you the number of protons, and it also tells you the number of electrons. Okay? So sodium, of course, has 11 protons. And if you go to the periodic table, sodium, Na, which is right here, look at that. It has 11 protons. Remember, this upper left-hand number tells you the protons and the number of electrons. So if I just told you sodium, you should know to be able to go to your periodic table and get the number of protons. If I just told you sodium, and you should get the number of electrons too. So how many protons does this sodium 2311, how many protons does it have? It has 11, because that number right there is your atomic number. How many electrons? It has 11. This number tells me that. How many neutrons, though? What does the mass number tell me? It tells me the number of things that have mass. What has mass? Protons plus neutrons. So if I know the number of protons plus neutrons, and I know the number of protons, I can figure out the number of neutrons. If I subtract the protons from the protons plus the neutrons, all I'll be left with is neutrons. So 23 minus 11 is the number of neutrons, which is 12. So here's cobalt. Cobalt, if we go to cobalt on the periodic table, which is, where is cobalt? It's down in here somewhere. Let me see if I can find it. CO, drawing a blank. God, it used to be right over here, wasn't it? It's a metal. Here it is. I'm sorry. Cobalt's right there. It's a transition metal. Look at that, 27. That's the number of protons, okay, and the number of electrons. So here's cobalt, but look, it gives it to us, but it doesn't have to. But it tells us 27, but we know that. We could have gone to the periodic table and looked it up. And then this number right here is the mass number, which is the number of protons and the number of neutrons. So what is the mass number? Very easily, it's 60. Okay. Protons, I think you know it, 27. Electrons, 27. Because that number there, that atomic number tells it to us. The neutrons, well, we got to figure that out. We got to take 27 and we got to subtract it from 60. 30, 50, 60, 33. How about chlorine 3717? Now you better believe if we go to the periodic table, we look in that upper left, we're going to see 17. That's the atomic number. This is the mass number, because remember, we're not talking about every average chlorine with the average weights. We're talking about this specific chlorine that weighs 37. That's the only time you put it in this type of isotopic nomenclature like this, right? This isotopic form. So the mass number is 37. I think the protons, you know, 17. The electrons are 17. And the neutrons is the protons minus the protons plus neutrons. And that is 20. Okay, I'm going to let you do this bottom one on your own. Uranium 238. This is actually what they use to make atomic bombs with. Okay, and then nuclear power plants. Is this specific isotope of uranium. 238. The protons are 92. In order for it to be uranium, it will have 92 protons. The electrons for this is 92. And it's whatever 238 minus 92 is. So I'll let you get your calculator out. It's 238 minus 92. All right. So here we are. We've expanded ourselves now. So in the book, when I speak to you going forward, I'm just going to say boron 11. What's the mass number? That's the mass number, 11. But how many protons? Well, you've got to go to the periodic table. Okay, you've got to go to the periodic table. And boron is right here. How many protons? There are 5. How many electrons? There are 5. So boron 11, how many protons? 5. In order for it to be boron, there are 5 protons. There are 5 electrons in this boron. So how many neutrons are there? Well, the mass number is the protons plus neutrons minus the protons. That's 6. Okay. Phosphorus 30. What's the mass number? 30. It's protons plus the neutrons. How many protons? Well, you got to go to the periodic table. And I'll give it to you. It's 15. Okay. When there is no charge, it's just plain phosphorus, there are exactly 15 electrons for 15 protons. The net charge is 0, right? Plus 1, minus 1, plus 15, minus 15 is 0. But how many neutrons? 30 minus 15 is 15. All right. So let's go to, let me go to your, let me go to your homework here. So here's your homework. So a couple of things very simply. What are the 3 things that make up, the 3 subatomic particles that make up an atom? Okay. Write them again, and then what are their charges? Write them again. What are their charges? Where are their locations? Okay, that should be very quick. Here's a neat little thing I threw at you, though. Helium has 2 protons, 2 electrons, and 2 neutrons. Okay? I want you to kind of, here it is, I want you to draw it. So where would the protons and neutrons be? There's 2 protons and 2 neutrons. Put P for proton and N for neutron and put those in the right spots. And then put an X for your 2 electrons. And just to let you know, this was like the electron cloud out here. So I'd like you to kind of put them in the right spot. Here's carbon 12, carbon 13, and carbon 14. So what is the element? I think I just told you. What does the 6 refer to? What does the 12, 13, and 14 refer to? How many protons and neutrons are in? Whoops, sorry. How many protons and neutrons are in the first isotope? How many protons and neutrons are in the second? You can add them together. How many protons and neutrons are in the third one? Pretty simple. And then you've got a chart to do, which is this. So there's calcium 39. The atomic number is 39. Right? I'm sorry. That's wrong. The mass number is 39. The atomic number you've got to go look up. Calcium, I will tell it to you right now. It is 20. So there you go. Whoops. Let me see if I can write on this thing. Anyway, the atomic number here is 20. If I'm right on, I got to erase it. The mass number is right there, 39. The protons is the atomic number. The number of neutrons is the mass number minus the number of protons. The electrons is the same as the atomic number. And the symbol is Ca. Okay, fill this out, turn it in. It's due by the end of the day on Tuesday when we come back, the 8th. Any questions, let me know. I'll be happy to work it out with you. Thank you for watching this. Be safe. Have a great Labor Day. Bye.